Okay, let's start with the basics of hydrocarbons and organic chemistry. First up, the term organic. What does it mean in chemistry? It means something different than what it means in the supermarket. Okay? In chemistry, organic means the molecule contains carbon, at least one carbon. Okay? So all these molecules here, they are organic. They contain carbon plus some other elements. That's all it means. It must contain carbon. Carbon can form chains, carbon can form rings, carbon can form sheets, carbon can form all these different interesting structures. And so organic chemistry is just a crazy, amazing field of study. Okay, now a related term. What is a hydrocarbon? Hydrocarbon. It's a molecule that's made only of carbon and hydrogen. Okay, so yes, they're going to be organic, but then they're a little more specific. These two are not hydrocarbons. Okay, this one right here, kind of in the middle, contains a nitrogen, and it contains an oxygen and another oxygen. And then this one contains an oxygen. They're not hydrocarbons, but the remaining three, those are hydrocarbons, just carbon and hydrogen. Okay, so real quick, can we figure out which ones are organic and which ones are hydrocarbons? Let's try labeling them as organic first, starting in the top left. Is it organic? Yes, it's organic. Yes, it's organic. Yes, it's organic. This one in the middle, yes, it's organic. They all contain carbon. That contains carbon. This contains carbon, and this one contains carbon. Ammonia, not organic, doesn't contain carbon. Okay, which ones are hydrocarbons? Only carbon and hydrogen. CH4, that's a hydrocarbon. That ethane over there, that's a hydrocarbon, but not CH3OH. What about this long one in the middle? Yes, it's a hydrocarbon, nothing but carbon and hydrogen. What about that benzene ring? Yes, that's a hydrocarbon. C5H10, yes, it's a hydrocarbon, and that's it. Acetone has oxygen. It's not a hydrocarbon. Ammonia is not a hydrocarbon. It doesn't contain any carbon. Okay, it's not organic, and it's not a hydrocarbon. A great thing to remember is carbon is always going to form exactly 4 bonds. So in this chain of carbons, or in this methane CH4 molecule, carbon always behaves the same wherever it is. It's going to form exactly 4 bonds, even if there are double bonds. Okay, let's have a look at this one over here. We've got this double bond right here, but each carbon has 1, 2 from the double bond, and then 2 more from the hydrogen. That's 4 bonds, 4 bonds. Okay, carbons always form 4 bonds. A double counts as 2. A triple bond counts as 3. Okay, so this carbon right here has 3 bonds from the triple and 1 from the hydrogen. It's got 4 bonds. This carbon right here, 3 from the triple, 1 from the bond over to this other carbon. It's got 4 bonds. All right, these two terms actually are logical, saturated and unsaturated. Think of a sponge. A sponge is saturated when it's totally full of water. A dry sponge is unsaturated. You could fit more water in an unsaturated or dry sponge. Okay? When we look at molecules, a carbon molecule like C6H14 that's all single bonds, it's absolutely full of the maximum number of hydrogens. But this C6H12, which has a double bond in it, it's not completely full of hydrogens. If we broke this double bond, we could fit in some more hydrogens. If we made this a single bond, we could fit in more hydrogens. So saturated basically just means it's all single bonds. Unsaturated means it has double or triple bonds, and if you broke those double or triple bonds between the carbons, then you could fit in some more hydrogens. It's not saturated with a maximum number of hydrogens. All right, so a little bit of terminology. Up top, we've got the name pentane and the formula C5H12, the name methane and CH4. These are the structures down below. So the molecular formula is what we call the plain old formula, like H2O or CH4 or C2H6. It tells you the number of each element in the compound, like C5H12, like CH4. The structural formula shows you how many of each element, and it shows you the actual arrangement of atoms in the molecule. Okay, so C5H12 is the molecular formula. Here's the structural formula of C5H12. CH4 is the molecular formula. Here's the structural formula. Okay, structural formula shows you the structure, the arrangement.